The sand casting process is a popular method to produce shaped parts weighing from less than a pound to several thousand pounds. The process is versatile and cost-effective even for low volumes because of low tooling cost. Nearly any part configuration that can be made using another casting process, including those with internal passageways, can be reduced to a pattern and created as a sand casting. To begin, a pattern of the desired finished part, including the metal delivery system of gates and risers, is constructed out of wood, urethane, metal, or foam. Sand, which contains a bonding material to hold its shape, is packed around the pattern. The pattern is removed from the bonded sand, leaving a cavity in the mold that is the shape of the part. Molten metal is poured into the cavity and the metal solidifies. The sand is removed through a shakeout process, and attachments, including the metal delivery system, are trimmed, leaving the desired part. As an alternative to creating a physical pattern, many customers take advantage of Metaltech's patternless molding. Using this technology, a reverse of the casting is machined from sand or other material to create the mold. Production then proceeds normally. Timing is quicker, design changes are easier, and hard patterns do not need to be stored or maintained. To learn more about this process, or to determine if it's a good fit for your application, give us a call or go to metaltech.com. Metaltech International, because you demand more than metal.
To the average person, the terms soldering, brazing, and welding, which all mean to join two or more metals, may appear synonymous. However, I'm here to tell you there is a difference. The main difference being the temperature. You see, when we talk about soldering, it can refer to hard or soft soldering, and solder alloys with melting temperatures below 840 degrees Fahrenheit are considered to be soft, and any soldering done above 840 is referred to as brazing or hard soldering, also called silver soldering when a silver alloy is being used. As for welding, the process occurs at a much higher temperature range, well over 5,000 degrees Fahrenheit. The second difference is the tools being used. Due to the high temperatures required for brazing, a torch or furnace is needed, whereas soft soldering can be done with a regular soldering iron or heat gun, as you would in electronics. Many production lines will also use wave soldering baths and special ovens for their electronics work. Last but not least, welding is commonly performed with a MIG, TIG, or arc welder. The final difference is the process by which the metals are joined. For soft and hard soldering, the process will be the same, where the solder has a lower melting point than the metal it is being applied to. The solder will simply melt and bond to the workpiece in a process called wetting. In welding, however, the actual workpieces are melted and a filler metal is added to form a weld pool. This process joins the metals through fusion and the joint becomes stronger than the original base material. Alright, so let's do a quick review. Remember that the temperature range is the determining factor between soldering, brazing, and welding. So if you are unsure, just look at the temp requirements for the job. Second, the melting range of the solder depends on the alloys used. Different mixtures of metals will have different melting points and therefore different heat requirements. And finally, the higher the melting point, the stronger the joint will usually be. Well, that's it. If you have any comments or questions, please leave them below for us, and please hit the like and subscribe button if you'd like to see more of our soldering videos. Thanks for watching.
3D printers have been used to make all kinds of amazing objects, like prosthetic limbs for children, actual biological tissue, working bicycles, and they've even been used by astronauts to print objects in space. So for all you Harry Potter fans out there, we're now going to show you how you can create a Harry Potter set of glasses for yourself on a 3D printer using plastic. The first step in the series is to take the digital file of this object and examine it for errors. Once you have a correct file, we can move to the next stage, which is to actually decide the print settings for this object, the speed of the print nozzle, the temperature that you will melt the plastic to before printing, and many other similar details. Once you've worked out this set of settings, you feed this into the computer and then hit This technology is being used by people in a very wide range of sectors, including product design, architecture, aerospace engineering, jewelry design, automotive engineering, and defense. If you have an object that's quite high in its vertical dimension, this means that the printer will have to make a large number of horizontal layers, each one above the other, while making your print. This will increase the print time. Typically, print time varies from about 15 minutes to 10 hours. The most common materials for 3D printing are plastics such as PLA, ABS, and nylon. But you also get printing technology these days that can make objects from ceramic or metal powders and convert them into actual metal or ceramic objects. With this technology, manufacturers can customize every single product to your own specification. For example, if you're ordering a car, you could order the car in one of many different body shapes listed on the manufacturer's website, or perhaps even in a shape that you have designed. You can create a new cover for it instantly right in this office. While printing, you have to be careful that the geometry of your object is clean and that your print is not shifting during the print. You have to keep it anchored and firmly stuck to the build plate. In addition, you have to ensure that any cantilevers or projections from the print are handled correctly by the printer. It's the speed and ease with which you can create these physical models of your ideas and products that actually transform the whole design process. Printers at the moment are available in the price range of say 50,000 to 2 or 3 lakhs for the most basic technology, which is called FDM or Fused Deposition Modeling Technology. The next other more expensive technologies are SLA and SLS printers, which can range from 3 to 6 or 7 lakhs each. While the market in India is just starting to take baby steps, we feel that in 2015-16 the market is really going to explode and affect all of us in ways that we never imagined.
3D printing or injection molding? Let's talk about it. Alright, let's start out with injection molding. I have here a little aluminum mold that makes a headphone cord wrapper in the shape of a fish. So first thing we're going to do is clamp the mold shut with some screws. This keeps the mold from being blown open by the injection pressure. Now we've got a hot glue gun which heats the plastic so we can flow it into the mold. We had to wait some time for the plastic to cool, and we can go ahead and open up the mold, and there you go. There's an injection molded part. So we can take it out of the mold and then trim the part off, and here you see it's a headphone cord wrapper.
So now let's take a look at a real industrial molding machine.
So this side of the molding machine is kind of like that hot glue gun. It's the injection unit. It's what melts and injects the plastic into the mold. And this side over here, this is the side that's like the screws. It's the clamping mechanism. We have the mold over here, so it opens, closes the mold, and ejects the parts. So now you can see the machine in operation. Mold opening and closing, the plastic injecting now. Give you a couple different views. We can zoom in on the machine operating. Mold opening, here comes injection. So I have sped up the cycle time here a little bit, but this is taking about 50 seconds in between each cycle. So that's that injection unit injecting the plastic into the mold, and then the parts ejecting. Notice that this is an 8-cavity mold, so 8 parts every 50 seconds equals about 6¼ seconds per part. Very fast. Alright, so let's compare this to 3D printing. Here I'm showing fused deposition modeling with a hot glue gun. We have a triangle that we're building up one layer at a time. This is how FDM printing works, is we put down with a little nozzle little traces of plastic one layer at a time, building up the product. Okay, so there we end up with a triangle with some thickness. Now we're printing the same fish that we injection molded earlier. The injection molded part took about 2 minutes to mold, less than 2 minutes to mold. Using injection molding with a hot glue gun. Would have been substantially faster in an automated machine. But here on this desktop 3D printer, to get a fish of even somewhat similar quality, this is taking about 1 hour and 16 minutes.
Hey, thanks for taking the time to watch this video. Watch for part 2 of this episode where we'll talk more about the differences and similarities between 3D printing and injection molding. If this has sparked your interest in injection molding, come on down for a tour. I'd love to show you what we do to train people for the injection molding industry.
Our shops and supermarkets are filled with products that are packaged in plastic, produced using the blow molding technique. The plastic blow molding process is the most popular method used to produce hollow containers. Impact uses a variety of raw material during the blow molding process, depending on the container application and its expected performance. The raw material in granular form is fed via a hopper into the feed barrel, which is heated to help melt the granules and evenly disperse the colorant, called master batch. A molten tube of plastic, called a parison, is extruded from the machine head and cut with a hot blade. It is then captured by a water-cooled mold, and a blowing nozzle is inserted into the parison. A blast of pressurized air is blown into the parison, forcing the hot plastic to take on the shape of the mold. This process is called blow molding. Once cooled and solidified inside the mold, the machine opens the mold and the brand new container is ejected. The container is transferred to a deflasher that removes the excess known as the tail. This excess is conveyed to the beginning of the process to be ground and reused. This is known as a closed-loop system. Once the jars leave the machine, they are then conveyed to a trimmer, which removes the remaining excess, called the lost head, which in turn is collected and added to the closed-loop system. With the tail and lost head removed, the plastic jar or container is now in its final form. Bottles are subjected to a leak test, whereby controlled airflow is released into the bottle. Should the bottle contain any leak-related defects, the pressurized air will escape and the bottle will be rejected. This bottle will then be introduced back into the closed-loop system. The containers are now ready to be packaged and sent on to the manufacturers of the products who will fill the new container.